Hello everyone and welcome back to another video. Today we'll be discussing how to read and write both multiple and complex objects to and from disk. To do this we'll be using a process called serialization. In this process, Java objects are converted to a series of bytes and then they're saved in persistent memory or streamed across a communication network. For this demonstration we'll be using a binary file to store our serialized objects. These bytes can then be deserialized, which converts them back into an exact copy of the original object. In order to make sense of this tutorial, you'll need a basic working knowledge of Java programming concepts as well as object-oriented design. I've included starter files in the description below. As a first step, I'd encourage you to pause this video and download them so you can familiarize yourself with the code and follow along as well. Alright, our next step is to create the object we wish to serialize. For time, I've already created this DummyNode class, and we'll walk through the important pieces of it. To serialize an object, we need to implement the serializable interface. This will tell Java that it's safe to convert our whole object, its data, and its methods into bytes. The other important thing to note here is we have an offset variable that's going to store the position at which we're going to store this array of bytes in the file. This is important for writing and reading to the file, and really key for using serialization with multiple objects. The other interesting thing here is we have an array list of integers. So we can actually serialize an object which holds other objects. Now with that, we have an object we can serialize, so let's start to implement the functionality in our Serialization.Example.java file. So let's first fill out some variables we'll need. We'll be using a RandomAccessFile as our binary file that we're reading and writing to. Once our serialized objects are ready, we will shove this in this file and then get them from the file when we want to deserialize them. We'll need a position, we'll call offset, at which we are at in our file. We'll use this for testing mostly. It will be just basically where we are in the file. And finally, we'll need a max node size. This will just allow us to allocate space in our random access file for each node as we go. So let's jump into the serialize method. We'll be passing a dummy node here. First, let's declare a byte array. We'll call it stream and just set it to null. We'll also want to return this stream at the end. This will store the array of bytes we're serializing. We're going to use a ByteArrayOutputStream class here. We'll call it BAOS. Call it whatever you like. This will aid us in the process. We're also going to use an ObjectOutputStream. All the classes we're using are linked in the description. I'm not going to go into a thorough explanation of them, but I encourage you to check out the APIs posted in the description below. We'll want to pass the ByteArrayOutputStream here to the ObjectOutputStream as a parameter. And then we'll want to invoke a few functions. Also be sure to surround this with the try, catch, or throw the exceptions. So we'll say output object stream, write object, and pass the node, and then we'll say our ByteArrayOutputStream and to use the 2-byte array and set that equal to our stream, and we'll return our stream, and that'll do it for serialize. So let's take a look at our deserialize method. Here we're taking a byte array called B, and we will convert it back to our object. So we'll start off by declaring a new ByteArrayInputStream. We'll call it in, and we'll need to import this as well. We'll also be using an ObjectInputStream. We'll call it IS for InputStream, and we'll pass it our in variable, the ByteArrayInputStream, as a parameter. We'll import that, and then we'll return our IS and invoke the readObject method. This will get us an object back, but we need to be sure we cast this to our specific object, in this case the dummy node. And that'll do it for deserialize. Alright, so our next step is to tackle the disk write. Takes in our dummy node as a parameter and our position that we will write it to the file, which this will be offset because we're keeping track of offset. So first, let's make a byte array and set it equal to our serialized node. We'll call that serialize method there. Next, we're going to use our random access file and seek to the position, that offset position at which we want to write it in the file, and then we'll use a random access file write method to write that array of bytes. Reset our offset variable, and then we're ready to move on to disk read. Next step will be disk read. Now, disk read takes in the position at which we want to read. So our first step will be to make a byte array, and we will set it equal to our max node size to ensure we have enough space to read in that full node. And then we'll make a new dummy node. We'll call it copy node and just set it to null for now. This will store the value once we've deserialized it. So we'll want to seek to the position in a random access file at which we want to read, and then we'll want to use the read method, and we'll read it into our array B, which we can just do by read B, like that. We'll set our copy node equal to deserialized of B, and then we will be good to go. We'll just return that copy node. So let's test out our code here. In this main method that is included in the starter files, we are simply instantiating a random access file and then reading and writing some nodes to that file. So if we run it, we can see here that our new copy node matches the value of its corresponding original node. With that, I hope this video was helpful. If you have any questions, please leave them in the comments below. And remember to give that subscribe button a click. Thanks for watching, and we'll see you in the next one.